Right, welcome everyone to part 4 of this lesson on hexadecimal numbers, and for this part we're going to be looking at how to add hexadecimal numbers together. Now this video has been recorded in January 2021, and during this time it's not a requirement for you to learn how to add hex numbers together for GCSE level exams. But it is a good skill to know, and it will strengthen your knowledge of hexadecimal numbers a little bit better. So let's have a look at some hexadecimal addition. Let's first of all start off with a very basic addition. So if we have, for example, 5 plus 5, 5 plus 5 equals 10, but you cannot write this at the bottom of this addition because this would actually be equals to 16. If you recall, we have the two place values 16 and 1, and if we put 1 and 0 underneath these two, then we have 1 times 16, 0 times 1, which equals 16. So if you recall what symbol we use to represent the number 10 in hexadecimal numbers, this would be equals to A. So this would be the correct solution to this problem. If you have, for example, a number like this, so if you have A plus 6, which give us 16. Now there isn't a single number in hexadecimal which represents 16. So if we add these two numbers together, we would get 16. So if we write 16 in hexadecimal over here, we would take the 0, put it underneath this column, and then we would carry the 1 over to the next column, and then obviously bring it down like this. So it follows the same basic concepts of addition that you've done throughout your life, except it's with hexadecimal numbers. Now let's have a look at a more complex addition here. So we have 1a plus a1, like so. So a, which represents 10, 10 plus 1 gives us 11. So we would write b underneath this column because b represents 11. And the same on the other column, we have 1 plus 10 give us 11. So we can write b here. So bb is the solution to the addition above. Let's have a look at another one here. So we have 1f plus f1, like so. Now f, which is the highest number that hexadecimal notation can represent, 15, plus 1 give us 16. So the same as above, we're going to write 16 over here because it requires 2 digits. We're going to take the 0 and put it underneath this column, and we're going to take the 1 and carry that over to the next column. Now 1 plus 1 gives us 2, plus f, which is 15, give us 17. Now 17 is represented as 1 1, like so. So we take this 1 over here, we put it underneath this column, and then we take this 1 and carry it over to the third column, and then we drag it down to the end here. So 110 is the hexadecimal representation of 1f plus f1. Like so. It may look like a binary number, but in fact it is a hexadecimal number in this case. Okay, let's have a look at another problem. So we have a5 plus b1. So 5 plus 1, very simple, 6. We don't need to go into the second column. We don't need to carry anything over. So we're going to write 6 here. A plus b, so that's 10 plus 11, give us 21. And to represent 21 in hexadecimal numbers, we use 1 5, like so, because 16 plus 5 give us 21. So 15 or 1 5 is the hexadecimal representation of 21. So we take the 5, we put it underneath this column, we take this one, we carry it over, and we bring it down like so. So 156, it may look like a decimal number, but in this case, because we're working in hex, 156 is the solution to the A5 plus B1 problem above. So 156 is the correct answer.